Welcome to this final part of the presentation on question 4, rather long question of STEP paper 2021 paper 1. We've still got to, the other presentations dealt with all of the problem except this very last part here. We've got to show, we've got to find all the solutions of cosine of a third tan to the minus 1 y is equal to 2 over root 5. And from the earlier part, we know, although it wasn't quite in this form, the cosine of a third tan to the minus 1 of 11 over 2 was equal to 2 over root 5, which means that y is equal to 11 over 2 is one solution, but we're asked to find all of the solutions. And in the preamble to the earlier presentation showed that if you've got cosine, you know what cosine, you're looking for all the cosines, then if you do 2n pi plus or minus the solution you've got, that gives you all the solutions. So that should tell us here, given that we know that a third tan to the minus 111 over 2 is one solution, that should tell us that all the solutions for a third tan to the minus 1 of y is equal to a third tan to the minus 1 11 over 2 plus or minus that plus 2n pi, where n is apparently, at least from this part, it's any integer. Now, in fact, for similar reasons that we gave before in the earlier presentation, if tan to the minus 1 is going to be a function, then it produces answers in the range minus pi over 2 to pi over 2. And that means, if you work this out, that actually n can't be any integer. N actually has to be equal to 0. But if you missed that, in fact, in this problem, it wouldn't make any difference. But anyway, we'll press on here with this equation here. I'll just change color to finish here. No, not to that color. I've used that one already. What have we got here? We'll go to some other color, see what this one looks like. Let's take this equation here, and let's multiply by 3. I've got tan to the minus 1 of y is equal to, let me change the order of these, it's equal to 6n pi plus or minus tan to the minus 1 11 over 2. So I want to solve this. So by the way, n is 0 in fact, so this term can disappear, but I'll just show you why it doesn't make any difference in this case. I apply tan to both sides, so it's tan of tan to the minus 1 y, because it's y I want to solve for, is equal to tan of this big thing, 6n pi plus or minus tan to the minus 1 11 over 2. And this is y, because tan to the minus 1 of y is just y. And now I've got tan of a lot of pi's plus or minus this. Well, because of this business about the range of tan to the minus 1, I know n's 0, but even if it wasn't the case, tan of 6n pi wouldn't change. It's periodic in pi, so 6n pi I can write this as tan of plus or minus tan to the minus 1 11 over 2. And now one other fact about tan. If I've got tan of minus anything, minus a, let's say, that is equal to minus tan of a, which is one of the properties of tan. You can kind of see it from the graph. It's an odd function. That tan of, you can take the minus on the other side of the tan. So that means this is equal to plus or minus tan of tan to the minus 1 11 over 2. And tan of tan to the minus 1 of anything is just the thing itself, so that leaves us with plus or minus 11 over 2. And that's the answer. We knew already from the beginning that y equals 11 over 2 was one solution. We've just shown there's two solutions. The other one is minus 11 over 2. So that finishes this rather long problem. If I had this in an exam, I don't think I'd be very happy, but we got to the end eventually. So thank you very much.